Welcome to the project demonstration of adaptive reactive power control of PV power plant to improve the power transfer capability under ultra weak grid connections. So here the application is whenever we are going to provide the supply in two ways, one is solar and there is a grid. So from the substation grid section and there is a solar. So here we are going to making use of MPPT, so maximum power point tracking. So whenever the voltage waveform and current waveform matches in a graph, like when more sunlight will get the more voltage, like we are using a solar panel. So this is the solar panel we are going to making use of. So the rating of the solar panel is 12 volt 20 watt solar panel. So from this solar panel we are going to input this section. So like we are using a 12 volt solar panel though, but it will generate up to 18 volts under the full sunlight. So when we get the more voltage, then in order to maintain the 20 watts power, the current will be decreased. So in order to maintain the high current at the high voltage with maximum power, then we are going to making use of microcontroller with MOSFET. Then it will regulate the voltage to make it as 14.5, which is sufficient to charge this battery, and nothing but solar panel. And that was given as input to this MPPT circuitry, so that will be converted to MP using a DC to DC converter. And after this, the same signal voltage will be given as input to the battery, and after that battery will given as input to the DC to AC converter circuitry. So here we are using single bridge H bridge circuitry inverter purpose. So from this IC we are going to generate the 50 to 50 hertz of clock frequency, and it was given to this two MOSFETs. So the MOSFET will get the input voltage of 12 volts 2 amps, that is a 24 watts power given as input to this MOSFETs, and the same signal will be generated as a 12 volts. So the 12 volts AC signal will be given for this step up transformer, and from here we are going to get the AC voltage of 230, so which is given as input to this load directly. This is a one way, solar panel DC to DC, and from here DC to AC, as well as from the substation also we are going to get the directly DC power supply to the battery, and directly here DC to AC directly. So in this way we are going to achieve the power transfer capability under the weak grid. So whenever this grid supply is weak, then the microcontroller will control this to get the more power using the MPPT, and this is the boost converter also. Okay, so here the load is like when we after connecting the load, just in order to utilize that, just we are going to making use of this, and whenever the heavy load is detected at this load section, one more light will be indicated as the overload indication with the LED on. So coming to this motherboard, we are making use of PIC microcontroller in order to provide the clock pulse input to this one based on the voltage levels, as well as we are going to control this battery to this inverter circuitry from this charging of the substation. Thank you.